Alright, so here's a little video about the Print3rBot, and we're just trying to plot our initials. This is the sheet I gave everyone over here to plot their initials on. You'll note that on this sheet the origin is actually way down here. 0, 0 is right here on this plot. This green area here, this fan-shaped area, is the range of the arms of the robot. If you take the gears off and you just kind of sketch out how far the arms can reach, this is about how far it can reach on our piece of paper. We found that when we ran the program that the printable area is actually smaller than that, and so I would limit your area to, the highest I would go to would be about 26 for the y coordinate, and I wouldn't go any further left than -3. So I think that would be the top part. And then, just to make it symmetric, I would try to keep your initials in maybe this box. That's a little tight right there. I'd like the initials to be at least maybe, I guess it would be 3 squares wide, and then let's see if we count. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so they have to be 3 squares for the width of each letter, and then maybe a box or a column of squares in between, and then 3 more column of squares, and then 3 more. So you can get all 3 of them in there. I'm going to only require that you put in 2 initials, so your first name and last name initials, so you have more than enough space to do that. You might make your letters 1, 2, 3, 4, 5. Yeah, maybe 5 high starting here, but try to stay within this box right here. So this bottom coordinate here would be, for x is -3, and for y is 20. -3, 26 is up here. This would be, I think that's 9, 26, and then this is 9, 20. So try to keep your points in here. Now remember, we're going to go over how to set up the points in a second, but they have to go in a certain order, and you have to do it a certain way. Now switching over to the software, this one is called plot4-1 initials.ev3, and you can get to this off the homepage in Canvas. This is one of the files that's available right there off the homepage on a previous day. The problem is when you open it up, it doesn't show you the main program. This is one of the My blocks that we use. So to get to the right place, what you want is go to the program list here and choose program.ev3p, that one there. And that brings you here. Now, if I zoom out a bit, you can see this is a very complex program. It took me quite a while to write, and this is just the highest level. There's tons of programming hidden in my blocks as well. But the question is, what do we change in this program to make it work? The things we changed are these 2 spots right here. There's an array called x's, or a list called x's, and there's a list of numbers called y's. And if you look at these lists, there's a couple problems with this user interface. You can't see the whole list. You can't make this bigger to see it. But there's a whole lot of numbers here. These, in this version of the program, it's going to just print out my name. But before you can change these numbers, you have to come up with your list of numbers that you want to put into the program. So I'm going to make that list now so you can see what that looks like. So here's my list. This one prints out my name, Dan, and you can see that along with all the x and y coordinates, I have certain commands that are listed here. In order to put the pen down and start drawing, you put in coordinates -1, -1. which is not in our printable area. So I use that to indicate that the pen needs to be put down. So that's a command to the robot, not a coordinate. The first thing I do is move to that starting location. I'm outside my box, like I mentioned earlier, just a little bit outside, but negative 419. So I'll move the pen there, but you can't draw yet because the pen's hanging in the air. It's going to have the pen up in the air when it starts the program. And so you have to put the pen down. So the next two coordinates would be -1, -1 with the command to put the pen down. And then these are just the points to print out the letter D. D, I don't have to pick up the pen until I'm done writing the whole letter and I'm back to where I started from. You can see there. So as soon as I'm done with the letter, I pick the pen up. Now the command to pick the pen up is 100, 100. That's also way off our sheet. So you couldn't plot that. And so I use that to indicate that the pen needs to be picked up. And then I move to the starting location for the next letter. And then this is the letter A for me. And so I move to that starting location, then I put the pen down. Don't forget to put the pen down. And then my letter A, I need to pick the pen up and put it down halfway through or partway through the letter. So you can see I move the pen to these coordinates, then I pick the pen up, I move to this coordinate, I put the pen down, make another line, that's the middle line, I guess. And then I pick the pen up and I'm ready to start the third letter. This is where the letter N starts. And so I move to this location, put the pen down, and then draw the letter N, and then pick the pen up. So your program is expected, or your coordinates are expected to always end with a pen up, and then it will move the pen back to the home position in the program. You don't have to put that in the code here, but always end the list of numbers like that. Now the problem with the Lego Mindstar software is you can't put in an array that has two elements in it. They only have single element arrays. So we have to put in all the X's separately and then put in all the Y's. And the mistakes people make here is sometimes they miss one on this list, and so the number of X's don't equal the number of Y's, and the program gets really confused. Or if you get off by one, things get scrambled. So you got to be really super careful on how you put this stuff in, because the user interface is terrible. If I bring up the code now, and I'm going to see if I can split window this. Oops, lost it. Where'd you go? There you are. Okay, so I'm going to see if I can get both things on the same screen. Here we go. And so you look at your X's over here. Here I'm near the top. And so I'm looking at this list here. I have to put all my X's in first, and then all my Y's. So I have -4, -1, -4, -1. I've got that there. But then here it's really easy to lose your place as you add things. And then we have two zeros, a -4, and a -1. Notice how they're matching up over here on the left. So go through your numbers and be super careful as you enter them. Now when you need to add more numbers to your list, you just hit this little plus sign. If you've added too many numbers, you can take one off by clicking this little X. But double, triple, quadruple check your list of numbers. Make sure all the numbers are there, none of the numbers are repeated, that kind of stuff. And then do the same with the Y column. Here's our Y column. And see, it starts with 19 and then -1, 24, 24. And so I've gone through these lists very carefully to make sure that the number of X's matches the number of Y's, vice versa. Okay. And this is the only thing you need to change to this program to make it work, is to put in these coordinates and save it, or run it, I guess. Make sure you're on this program page when you run it, but and just say go, and then off it goes. So so we're looking at now I don't have my robot here with me, so I can't run it, and you can see it's not connected at this point. But that's all you need to change to make this this work. Now, if you don't get this to work in your robot, so your robot builds a little bit sketchy, you can try it on my robot and that way we can verify that the coordinates are accurate. But that's the process of going in and putting in the coordinates to make this program run. I don't think there's anything else to say. So good luck with that. Hopefully this works out for you.